In 6.3, I'm introducing logarithms, which is a brand new word to you guys. Okay, to my knowledge, logarithms does not appear in Algebra 1 or anything. So this is one of those Algebra 2 topics that is brand new. Okay. Now, when we talk about logarithms, there is a button on the calculator that we'll be using some. There's actually two buttons because we'll talk about logarithms and natural logs. But a little bit of information here. A little bit of information. First of all, when we talk, the reason we're talking about logarithms now is because they relate to exponential functions. We've been talking about exponential functions this week and the end of last week. Well, here's the deal. Exponential functions and logarithmic functions are inverses of each other. So if we're working with exponential functions, there's a connection to logarithms. So what we're looking at here, log base b of x equals y. That's a common way you'll see a logarithm written, and it is equivalent to the exponential function b to the power of y equals x. Okay, we're going to learn, part of what we're learning is how to go back and forth between a logarithm equation and an exponential equation. But those are equivalent statements. Logarithms, I already read it out loud, but it's read as log base b of x equals y. So when you see that, it is important that you mention the base because the base is not always the same. Okay. The part you'll probably care the least about is this part right here, but this gives official definition. Logarithm base b of x is defined as follows. Log base b of x equals y if and only if b to the power of y equals x. Some restrictions. B has to be greater than 0. When I say b has to be greater than 0, I'm saying the base has to be positive. You won't ever see negative bases on logs. B cannot equal 1. Okay, so it has to be positive and anything but 1. And x, the inside right here, what we call the inside of the log, has to be greater than 0. And again, when I say greater than 0, that translates to positive. Anytime you see a fancy math statement that says greater than 0, your brain needs to simplify it to, oh, something's greater than 0, that means it's positive. Okay, I already mentioned several of these things. The logarithmic function is the inverse of the exponential function. Okay, we will, I think it's in 6.4, we learned to graph logarithmic functions. And when we look at that, I'll remind you how they reflect along that y equals x line. The inside parts, so the x value of a logarithm can never be negative. Okay, and in fact, when we look at the calculator, we'll do some practice, but you'll get an error message on your calculator. So the inside of a log can never be negative. So what's here in the x position can never be negative. Notice here it was stated as x is greater than 0. Exponential form, so a lot of what we're doing today is going back and forth between exponential form versus logarithmic form. Okay, so we're going to spend a lot of time going back and forth, but exponential form shows that a base raised to an exponent equals the result. When we take those same variables and reverse them, logarithmic form shows that the log of the result with the given base equals the exponent. Okay, this is going to be important to kind of put together, and we'll practice, but look at the locations. This one has a base of a on the exponent. The log has a base of a. This is a raised to this exponent equals a result c. Well, this is the log of that base of the result is equal to the exponent. So one of the things I think about is, okay, the base of my exponent is the base of my log. My b and c kind of flip-flop there. Okay? Or if you look up here, it's the x and the y values. Now, here's an example that'll probably make more sense than letters, I'm guessing. Logarithms and exponential functions can be switched back and forth by thinking, and this is the phrase you'll hear me use, left, right, middle. So, and left, right, middle works if you're starting with a log and going to exponential form. So, with this log base 2 of 8 equals 3. Well, 2 is the left value, 8 is the middle value, and 3 is the right value, if you will. Like if you're just looking at a log and it starts with log, 2 is the left value, 8 is the middle value, 3 is the right value. Well, if we're going to rewrite that in exponential form, the phrase we're going to use to help us, or a phrase you can use to help you, is left, right, middle. So it's the left value raised to the right value equals the middle value. And so here you have 2 raised to the 3 equals 8. So this is the left value raised to the right value equals the middle. So thus it becomes left, right, middle when we reorder the pieces. Okay?
Right.
I'm trying to think if there's anything else I want to mention there, but I think that gets the basics. Okay. So, you've got this in front of you. Keep this in front of you. I'm going to go on to my next screen where I have some examples. We're going to look at some of these. I tried to match up some of my example wording with the wording you'll see in homework. Notice this first section. Write each equation as an exponential equation. So right here, notice all of these answers are, all of these given problems are logarithms. They have a log in them. We're just trying to take them out of log form and write them in exponential form. So if you look back up here, we're trying to take it out of this form, and we're trying to put it into this form. Okay? We can do that by using the phrase left, right, middle. Or you can just work to understand the connections on your own. That is your choice. So, log base 10 of 1,000 equals 3. Well, left, right, middle. If I think left, right, middle, my left value is, if I just label these, 10 is my left value, 1,000 is my middle, and 3 is my right value, yes?
Yeah.
So left, right, middle says I'm going to rewrite this as how?
10 to the third equals 1,000.
10, so left raised to the right equals the middle. Now, does that just so happen to also be a true statement?
Yes, it does.
Yeah. Okay. You might have to do this with numbers. You might have to do this with variables. I think it's mostly numbers. That's all they want you to do there. When it says to rewrite this in exponential form, or write it as an exponential equation, that's it. Stop there. Don't go any farther. Okay? Thoughts on B then? Got a left value, a middle value, and a right value. How do I rewrite this using left, right, middle? Okay, what are you guys thinking?
2 to the 5th equals 1 over 32.
Okay. I think you might have left out one minor detail. Yeah. Got all the pieces in the right place. Just got to get nitpicky that, yes, the negative needs to be there, right? 2 to the negative 5th equals 132. I don't know if you realize it or not, but that is an equivalent statement. Because what do we do with negative exponents?
Put it on.
Take it to the denominator, right? Okay. Okay, what about C?
Oh.
Okay. Okay. You can work it like this. If you're looking at that and saying, no, that confuses me, what could you do? Could you flip it? Yeah, you could rewrite this as log base 4 of 16 equals 2. That left, right, middle phrase works when the log is on the left, when your equation starts with log. If it's given to you backwards, which they'll do, don't be shocked. Just rewrite it if you need to. So, what is log base 4 of 16 equals 2?
4 squared.
The left of 4 raised to the right of 2 equals the middle value of 16. And on these, it's kind of nice to see because the numbers are matching up. So, and what about D?
10 to
10 to the negative second equals 1 over 100. Did you reverse it if you felt the desire? Okay. If you don't like looking at it as is, it's log base 10 of 1 over 100 equals negative 2. Questions on that section? Okay. Now, let's look at this section. Notice, this next section is written how? Yeah. This is written in the exponential form, the form we were just giving answers in. It's written in the exponential form, and we're being asked to write it in log form. So logarithmic form.
I got it.
With that in mind, I like to think of it as it's undoing what we just did. Okay? You come up with what works for you. Are we killing bugs?
Yep.
Okay. Thoughts
Yeah.
on 3 to the 4th equals 81?
Log base third, and then 81 equals 4.
What do you guys think?
Yeah,
I think he's right on the money.
I agree.
Let me write down what he had. Log base 3 of 81 equals 4.
I guess.
Okay?
I got the third.
Okay, hold on. Now, you can check yourself here by doing a left, right, middle, yes?
Go south.
3 to the 4th equals 81. You can also, as I said, I like to just keep the base of 3. The base of 3 on the exponent is the base of 3 on the log, but then my 4 and 81 swap there. Okay, that was A. Landon, what about B?
I got log base 7, 343.
Okay. Log base 7 of 343 equals 3. Check your left, right, middle. 7 to the 3rd equals 343. It checks. I kept my base of 7. I switched my 3 and 343. C.
I got it, Frank.
Go ahead, Aaron.
Log base 13 x equals 1.
No?
Why not?
It's y equals x.
Okay. Are we all good with
No.
log base 13?
Yep.
Yeah.
Because the base on the exponent is 13, so the base on my log is 13, yes?
Yeah.
Yeah. Now, it was 13 to the x, so this log base 13 is going to be log base 13 of y
Wow.
equals x. Now, here's one thing I'm going to say, okay? Because I think the class was kind of split on that one. Could you reverse the original problem
Yeah.
if that makes it easier to see for you?
Yeah.
Okay?
Oh, yeah, I missed out.
Okay.
I got the next one, though. I'm bouncing back. Never missed 2 threes in a row. Coach Hawkins.
Wait. Oh,
Yeah.
no, I got that.
I've got it.
Are we good with the previous one?
Yep, I got it right here.
Okay. What do you got, Aaron?
I've got log base to the 5th, 1 equals 0. That's what I got. That's what I got as well.
Okay.
Never missed 2 threes in a row.
Log base 5, because 5 is a base. Log base 5 of 1 will equal 0. I think it's later in the chapter. One of our rules we know is that learn that log 1 of any base is always 0. We don't learn that today officially, but we learn it later on. So, and I will say, important thing to remember, I'll give you a hint about upcoming things later this lesson. 5 to the 0 equals 1, because we know anything raised to 0 is 1, yes?
Yes.
Okay, refresh that thought in your brain, right? Okay. Are we good? Got the basics. Because the first part of homework is doing just this. Okay? I mean, you've probably got, I don't know, 8 problems.
Oh, there we go.
So,
Now we're talking.
doing this. So, okay.
25.
Next section. we're going to practice evaluating. In other words, I want to know what log base 5 of 125 is equal to. Okay? Now, on this one, if you punch it in the calculator, you're going to get the wrong answer. Okay? This is not a calculator problem because, and we'll talk about this on the back side, our calculators don't do just any old log. That log button on your calculator only does log base 10. Okay? So this is where we have to know some of our rules. So, log base 5 of 125. I want to know what this equals, yes? So it's kind of like thinking, okay, what does this equal? Now, actually, instead of what does it equal, I'm going to call it x. Okay? Put whatever variable you want. And here's the deal. I don't really know how to work with a log, but I can go from log form to exponent form like we just did, right? So how can I take this? I just took this log and set it equal to x. So I kind of have a log equation here. How can I turn this into an exponent equation?
5 raised to the x equals.
Okay. Left, right, middle, yes? Anytime you guys see me write L-R-M or LRM, that's me saying, okay, think left, right, middle. So 5 raised to the x is 125. And now we have an exponential equation. Thoughts? Why 3, Trent?
5 raised to the 3rd is 125.
And how do we know that?
Because 5 times 5 is 25, and then 5 times
Yeah.
5 again is 125.
That might just be one of those values you're starting to have memorized.
Maybe.
Okay. So it's a good one to work to know. Okay. So the idea here, I'm going to rewrite this. 125, we've talked about in the past as 5 to the 3rd, yes? Because, and I guess here's the deal. You guys have those, what color are they? Blue papers? And if you look on the blue papers, 125, the cube root of 125 is 5, yes? So what I'm trying to get you guys to do here is, okay, 5 to the x is 125. Well, 125 is 5 to what power? And we know that it is 5 to the 3rd power. We do know that, right? Okay. If 5 to the x is 5 to the 3rd, guess what? If your bases are the same, your exponents are the same. So what we know, log base 5 of 125 is equal to 3. Okay. Questions there?
I got the
Are we okay with B then? Okay. And this is where, well, I'll talk about another option here in a little bit. But if you didn't know that 125 was 5 to the 3rd, you can play on it with your play with your calculator and figure it out. Okay, so B, log base 2 of 2 to the 8th. And again, here's what I'm going to do every time. I'm going to set that equal to x, so I can then rewrite it. How am I going to rewrite this?
Go for it. 2x equals 2 to the 8.
Okay. If I think left, right, middle, 2, the base of 2, raise the x on the right, is equal to 2 to the 8th. Might have made this one too easy. But here's the deal. I saw something like this in homework, so why not? What do you know?
I know that 2 to the 8th is 256.
Oh, that's too much work.
2 to the 8.
Isn't it just
X equals 8.
If we have the equation 2 to the x equals 2 to the 8, what is x in the same place as?
8.
8.
Oh.
X is 8.
Wow.
Yeah.
You're overthinking it, okay? It doesn't matter what 2 to the 8th is because we've already got that broken down. The idea here is if the bases are the same, then the exponents are equal to each other. So if I end up with the equation 2 to the x equals 2 to the 8th, Well, the 2's are the same, so the exponents equal each other. So x equals 8. Okay? Okay, C then. What are you going to do first?
Well, I'm not up there. Where's it at? Oh.
So,
And then you do.
what are we doing here? 3,
X, X.
3 to the x
Zero.
equals 0.
Well, how would it? If x equals 0, isn't it still 1 then?
No solution?
Yeah.
So, okay, the question is 3 to what power equals 0? There isn't one, is there?
No.
Now, your calculator does log base 10, but here's the deal. Type in log of 0.
Alright, I will.
Just hit the log button and then type 0 and then hit enter. Are you getting an error?
Oh, yeah.
Okay.
I got
So-
domain error.
What I'm going to,
Domain error.
Are you gonna type in domain error?
I'm going to use the vocabulary word undefined. Okay. Because here's the deal. It doesn't matter what base it is. Log of 0 will never exist. Okay, that graph does not exist at that point. Log of 0 will never exist. So once I hit that point, I'm like 3 to what power equals 0? Oh, wait, we can't do that.
Right.
Because if we do 3 to the 0, that gives me 1, but I can't do this. So if you get a situation like that, it's undefined. And I can't remember if they use another word other than undefined, but undefined, no solution, whatever variation they use. Okay, are you trying D?
Yeah, sure.
Are we having any luck?
16.
If I set this equal to x, right? Log equals some value. How am I rewriting this in exponent form? 1/4 to the x equals 16. You got a thought or a question?
-2.
Why -2?
Does it work on my calculator?
Because it works on your calculator. So did you just do trial and error? Okay. Not disagreeing with the answer. What's a method to get there? Other than just trial and error on the calculator.
Yeah, homeboy, had to get there.
He guessed the right number.
Don't just guess negative.
Okay. So
Right.
what do we know about fractions, guys? This 4 in the denominator.
It's equal to 0.29.
Okay. Don't go decimals on me. This 4 in the denominator. How do I get that 4 out of the denominator? And I can give it a negative exponent, right? So like right now, this is 4 to the positive first. Because here's the goal. I'm trying to get both sides of the equation to have the same base. So if I rewrite this as 4, and if I bring that 1 up, it's now 4 to the negative first, raised to the x. And now here's the idea, is I've gotten it out of fraction form, which is what I needed to happen. A power raised to a power. What's -1 times x? -1 times x is 4 to the negative x. Now, my left side has a base of 4. What do you know about 16?
Divided is divisible by 4.
How could I rewrite 16 with a base of 4?
Square root. Square root.
Okay, kind of. So how do I rewrite it?
What?
16 is 4 to what power?
Second.
So I'm going to rewrite this as 4 to the second. Sorry, I might not have been asking the right leading questions there.
Oh, no.
I had a lot of confused looks, but now, okay, what do you see at this point?
The exponent, like the
Yeah.
number B.
My bases are the same, yes?
Yeah.
It's 4 to negative x, 4 to the second. So if the 4's are the same, what's that mean about the exponents? They are equal to each other, right?
Yeah.
if negative x equals positive 2, what's your basic algebra skills tell you? X is negative 2. Does that make a little bit of sense? Maybe, maybe not. And this is as we work in this section, this is the tough type problem, right? But your job is going to be to work to get your bases the same. I saw a 4 and a 16. I know they can both be written as 4 to some power. It's just making it happen. Okay? Let's try E. Set this log equal to x, and I'm going to rewrite it. Rewrite it as what?
3x equals 1 over 81.
Okay. 3 to the power of x equals 1 over 81. Well, I see a 3. I see an 81. Some of you know it. Some of you are going to have to take your calculator and try it. Can I get 3 and 81 to have the same base? You could use your blue paper to help you.
Oh yeah, it's 4.
It's 4. Reach the 4. It's 4.
Note to self, don't hand the papers to Gatlin first next time.
Yeah.
Now, you can stuff this in the back of a folder somewhere and never look at it again. Or you can use it to help you. How can this yellow paper help me on this problem?
I'll do both. I'll use it.
I know you have to kind of figure out what's on the paper and get the lay of the land.
Why'd you break it in 4 to 81?
Okay, so here's the deal. If I am trying to figure out, I see a 3 in this problem and an 81 in this problem. Well, 3 is just 3. Can 81 be written with a base of 3?
Yeah.
Yeah, it can. 81 can be rewritten as 3 to the 4th. Now, some of you were starting to figure that out just playing around on the calculator, I think. Some of you might have known that one. Some of you it would have taken a while. So this paper, it's kind of like the blue paper from last chapter, can be used to help. And if you don't like it, don't use it. I don't care.
Oh.
So, I'm going to rewrite this. 81 we said is 3 to the 4th. So I'm going to rewrite this as 1 over 3 to the 4th. Now I could have done this all in one step, but taking the baby steps. What do you know about a 3 to the 4th in the denominator?
It's negative.
When you pull it, it's negative when you pull it up to the
Positive.
numerator, yes?
Positive.
So I can rewrite this as 3 to the x is equal to 3 to the negative 4th. And what do we know? If it's 3 to the x and 3 to the negative 4th, then x is
Negative x.
negative 4.
Negative x
Okay.
equals 4.
If you go back into our original exponent equation and you type in 3 to the negative 4th, you're going to get the equivalence of 1 over 81.
Hey Jason, it's hot dog sandwich.
I know.
Yeah.
Really?
I have full confidence Jason can read. Full confidence. I have more confidence than him maybe, but I have confidence. Okay. F.
Wait. What?
Log base 7 of negative 7. Every problem to this section, what am I having us do? Equal it to x, so we can take this log and turn it into an exponent. So if we turn this into an exponent, 7 to the x is equal to negative 7. So 7 to what power equals negative 7?
Negative 1.
What is 7 to the negative first? I would say 7 to the negative first is, how do I get rid of a negative exponent? 1 over 7. I need negative 7. Why undefined?
Because it is.
Well,
Other than because it is.
It is.
What do we have here?
a negative.
A negative. Go back up to the top of your notes. One of the statements made, the inside parts of a logarithm can never be negative. So for me, as soon as I see this right here, the fact that it's negative, I automatically know undefined. Now, your calculator is not base 7, but if you plug in log of negative 7 on your calculator, it doesn't matter what base, your calculator is going to give you a error message, right? Is that what it's saying, domain error? Okay, so this is another one that is undefined. Okay. And for whatever reason, I put one of the easiest ones at the end of this section. But then again, we struggled with one equivalent to it earlier, so it's good to come back to. Okay, guys, what do you got for G? Log base 5 of 5 to the 9th. I set that log equal to x. So now I can write this log equation as 5 to the x equals 5 to the 9th.
Boom. Got it. We gotta eat this.
The 5s are the same.
5s are the same.
The exponents are the same, so x is 9.
9.
Okay. Let's go ahead and do the calculator real quick. We can get A through F done in 5 minutes easy. So, okay, on the back, we have 2 sections. We're going to do one section a day. We'll save the equations for tomorrow. But at the top of the back, first of all, is a little bit of information. I mentioned the buttons on your calculator, right? So, some of you have been trying them. I've watched you. Sometimes they're giving you the right answer. Sometimes they're not, depending on the problem. That calculator works in base 10. When you hit a log button on a calculator, 99% of the time, you don't get to choose what base you're in. And so it's automatically log base 10, which is called the common log. Okay? When you see something that is log x and they don't put a base, what base do you have to assume that is?
10.
Log base 10.
Boom.
Now, you also have a second log button on your calculator. I mentioned it the other day, and that I think I did. That is the natural log button. And it is an LN button. And it is base E. We talked about E being that natural number, that 2.718 number. Okay, so if you see LNX, that is base E. If you see log X, that is base 10. So you have 2 bases you can do on your calculator. Base 10 and base E. Other than that, your calculator is useless. Okay?
Nice.
In this stuff. Now, notice, what do my directions say? Use a calculator. I don't even think I'm going to put my calculator on the screen. I have such confidence in you guys.
Wow.
Oh my gosh, I got it.
Grab a calculator.
Got one.
Log of 900. What do you do in the calculator?
You put the log button, then you put the 900, and you press equal.
2.954242509.
You guys getting a number like that?
There's 10,000.
Now. Okay. 10,000s. Count with me. Tenths.
Tens. Hundreds.
Hundreds.
Thousands.
Thousands.
4 numbers.
10,000.
10,000s.
So how many decimal places do we have?
100,000s.
4.
Why?
Okay. So when it says 10,000ths, this is 4 decimal places. So when you get 4 decimal places,
29542.
there's no work to show. Your calculator did the work. Now, why was I able to do that one on the calculator?
Because
It just says log. What base was this log 900?
10.
Thank you.
what is I? Oh,
Okay, so it was base 10, so that's why I could do this.
I have even.
So B, this is ln, so natural log of 1,215. So now we use the other button, yes? What base is natural log?
7.1. Oh,
024.
It's base E.
025. Yeah, pretty good.
7.102, and then that 4 rounds up to a 5, I believe.
Yep.
Yes.
Oh.
Are we getting these on the calculator? Tell me if you're not.
Speak up.
Okay,
And that's what's an
C.
error. It's an error.
what base is this?
Error.
It's base E.
Error.
Why might it be giving you an error?
Because it's
Negative, that's negative.
Okay, right there, guys. Because I see a negative, I don't even have to type that into my calculator. I know it's going to be
I knew that too.
undefined. Okay, D.
321.
Log of 321 is base 10. What's your calculator say it is?
25065.
2.5065.
Yes.
Okay.
Was it 2.18?
Now, natural log of E, it's base E, yes? Are we figuring it out?
1.
Depending on your calculator, you might have to then put a power on E, right? If you have to put a power, it's just a power of 1. So natural log of E to the first is what?
1.
1.
Oh, that makes sense.
Okay? And if we set this up as an equation, E to the X equals E, you'd have a first there. And log base 10 of 1700ths, negative point what? 7696. Okay,
Yeah.
you need to make sure homework from lesson 6.2 got done. We've done everything in 6.3 except solve equations. We'll plan to solve equations tomorrow and then I would think have some work time.